Okay, so it's 3 p.m., but since no one has joined in the session so far, so I'll wait for a couple of minutes and we'll then get started with today's session. All right, since one of you have joined this session, so I'll get started. Okay, welcome to this week 8 TS session. So today's topic will be on genetic algorithms. So this is the remaining portion of the genetic algorithms and which talks about one example problem and then talks about the real coded GA and then finally talks about also the multimodal functions. Okay, so the topic of discussion in this session will be first genetic algorithm. So this is mostly with precision problems. Next will be I'll be discussing about the main topic of this week. I think you have two assignment questions related to that as well. So it is on multimodal function. So where you have to adjust the fitness function. So adjusting fitness functions. And finally, I'll be talking about some of the concepts of real coded GS. And if there is some more time, I'll probably take another example problem and solve something. All right, so let's see the first question that I'll be discussing. So this is Q1. So suppose I give you a three variable problem. So this is a three variable problem, uh, say with bounds. So I give you some bounds of the variables. So suppose I give you minus 10 less than equals to x less than equals to 10. Next, say y, about y I can give you 0.01 less than equals to y less than equals to 0.05. And finally, I give you z, and z can be, say, between 10 square and 10 cube. I think you'll find a similar problem in your assignment as well. I have just modified the numbers here and there. So I'm asking you the minimum string length. So this is the minimum string length of any point, say x, y, z, coded in binary strings. So that I have to write coded in binary string, and the precision that I want, or the accuracy, whatever you call it, is of 10 to the power minus 2. So it's two significant digits. So let's try to solve this. So for this problem, so this is the pretty simple problem where you have the expression for the precision. So if I denote it by epsilon, so you know that it should be x max less than x min then divided by 2 to the power L. Say I write it as L, or you can write it as Li or something as well, so that's not a problem, minus 1. So this is the expression for your precisions, and now you have the expressions for your, like you have the bounds for your variables. So this x max for x will be like 10, and x min will be minus 10. Epsilon you can put 10 to the power minus 2, and you can find out the length of the string, which is L here. So let's solve this. So this epsilon is same across all the three variables that I have mentioned. This L will vary and this bounds will also vary. So suppose I denote the length for this x variable to be Lx, so I can write it as Lx here. So now let's solve this. So what you can do, we can put 10 to the power minus 2, and your x max is 10. This is 10 minus of minus 10, and then it's 2 to the power Lx minus 1. So if you solve this, you'll probably get this is 1 by 100. This is 10 plus 10, 20, and this is 2 to the power Lx minus 1. So what you can do, you can have 2 to the power Lx minus 1 equals to 2000, and finally you will get 2 to the power Lx to be 2001, and your Lx is nothing but log 2 base 2001. So this you have to calculate. So you can calculate it in your calculator. So let me do that just now, and I'll write down this. So this is 2 to the power, okay. So you will get 10.96 if you calculate this. And since you are dealing with the length of the string, so you have to round it to the next integer. So that means 11. So that's how you can find out the length of the string corresponding to x. Now you have to do this for Ly and Lz as well. So for that, you can again write similar kind of expressions. Epsilon is nothing but y max minus y min divided by 2 to the power Ly minus 1. So this is again 1 by 100. I think this is 0.05 minus of, this is plus right now, so this is 0.01. Yeah, and again, similarly, you have to write this. So if you calculate this, so this is nothing but again similar kind of expression. So this is 0.04 times 100. That means this is 4, if I'm not wrong. And then you have 2 to the power Ly equals 5, and Ly is log 2 base 5. And this will give you something, I think, in between 2 and 3, because you know 2 square is 4 and 2 cube is 8. So if you round it off, it will be around 3. Then finally, you have to do the same exercise for Z as well. So for that, what you have to do, you have this Z max minus Z min, and then you have this 2 to the power Lz minus 1. So I think the Z max and Z min was 10 cube and 10 square. So let me put that values here. So this is 1 by 100. This is 1000 minus 100 divided by 2 to the power Lz minus 1. So this part is nothing but 900 times 100. And finally, you will get your Lz to be log 2 base. This will be 90,001. So if you evaluate this, you will finally get something like 16.46 probably. So this will be 16.46, and you have to round it up to 17. So hope I have done it correctly. If not, you can tell me whether I have made a mistake or not. So hopefully you have understood this calculations should be right as well. So finally, what you will be left with is nothing but So the final length of the string is L equals to Lx plus Ly plus Lz. So that will be your 11 plus 3 plus 17. So that's probably 31. So this will be your final answer, and you will be asked, I think, a similar question in your assignment problem as well. It's pretty simple. It's not like you have to take the best of the tree that you are not doing, because you are getting an unique kind of string for every portion of this variable. So it's xyz. If you write it kind of side by side, you are, if you're converting it to binary with those precisions, then you need to have those many number of binary bits in for corresponding to x, y, and z. So that's why you have to add it up. So that's the only thing that you need to be careful for this kind of problems. So any question related to this? Otherwise, I'll move to the next problem. Okay. All right. So I think the most critical problem in this assignment related to this, so that I'll be discussing. So this problem, consider this functions. I'll just, again, as always, I'll modify this function. So suppose this is x squared sine x function I am given it. Now you have to maximize this function. So this is maximization problem. So the good property that you need to know that for the fitness function as well, you can use the same function in case for maximization problem. And now the lower and upper bound of the x variables I am given. So suppose this is 10 less than equals to x less than equals to 10. And now first, in case of any genetic algorithm problem, you have to generate some sort of a solution pool. And this also called as the population. So let me give you the initial population, and it is in terms of binary as well. So suppose I'm giving you this initial population, say 1, 1, 0, 1, 0, 0, 1, 0, 1, 1, 0, 0. This is 0, 1, 1, 1, 0, 1. Next is 0, 0, 1, 0, 1, 1. The fifth one is 1, 1, 0, 0, 0, 0. And finally, the sixth one is nothing but 1, 0, 1, 1, 1, 0. So these are 6-bit binary strings. And now I am asking you to modify the fitness function. So modify the fitness function with the sigma parameter, with sigma equals to, say, yeah, let me take it as 5. Similar problem to the assignment, but in the assignment, the function, I think, it's different. So that's the minor tweak I have made. So let's solve this problem. So for this kind of problem, the first thing you need to do, you have the initial population, and that's coded in binary. You can convert it into your decimal value or the decoded value, whichever you call it. So probably I can write it as DV. So let me write it in a different color, probably. Okay, so I think you have already learned how to decode a binary string or maybe convert it into the decimal string in the previous class itself. So corresponding to this, you can assume this 2 to the power 0 to 1 to square to cube to 4 and to 5. So you just multiply this and then add it up across those bits, and you will get the decoded value. So for the first one, it's you are adding 4 plus 16 plus 32. So it's nothing but 52 here. For the next one, you are adding 4 plus uh, 8 plus 32. So that's 44. For the next one, you are adding 1 plus 4, that's 5, then 8, that's 13, and then 16. So this is 29. For the next one, you are adding 1 plus 2 plus, that's 8, I guess. Yeah. So 1 plus 2 plus 8, so that's 11. And then I am adding 16 and 32, so that's 48. And finally, I'm adding 2 plus 4, that's 6, and then 8, that's 14, and 14 plus 32, that's 46. So this is your decoded value. I think you have understood how to do this. So I'm not explaining further on this. So let's try and convert it into the corresponding x values. So remember, we have this x variables to be defined between minus 10 to 10. And now this decoded value is something which is beyond this ranges. It's not lying between minus 10 to 10. So once you generate this solution pool and then convert it into the decoded value, if it's not in that range, then that's not of any use. So for that, we have to convert it, and conversion can be done with a similar equation that we have already seen in this class with the precision value and everything that we have seen. It's just slightly different. So let me write down that expression. So that you can write using this. So suppose this is your x. I can write it as xi. Then this you can write it as x min plus x max minus x min, which was previously this term corresponding to the precision. Then 2 to the power li minus 1 multiplied by your decoded value. So by this, you can convert it into that range of minus 10 to plus 10. And the reason being is that the maximum value that this decoded value can take is 2 to the power li minus 1 if we are dealing with a string of li minus 1, sorry, li. Then these two terms will cancel out and you will left with an upper bound of x max from here. And the smallest value this decoded value can take is 0 if your all of those binary bits are 0. So in that case, the minimum value that you are left with is x min. So that's the lower bound. So this is how we can convert it. So it's pretty simple to understand as well. So now let's convert it into this x values, which should lie in that range. So let me do that. So this is your x values. And I'll use this equation. So, okay, some issue with this. Okay, we have one more person joining in. Okay, so I have this decoded value. Now what I have to do, I have to convert it into x values. And let's see. So first is, you can notice this portion is common to everything. You will just replace this decoded value in everything and you get the corresponding x. This x min is also the same in everything. So let's try and write a simpler expression for this. So this part is minus 10. This is plus, this x max is nothing but 10. This is minus of minus 10. And since I am using this 6-bit binary strings, so this li is here, which is equals to 6. So this is nothing but 2 to the power 6 minus 1, then multiplied by your dv. So if I just write a simpler expression for this 2 to the power 6 minus 1, this precision factor, what you'll get is nothing but, let me just calculate and write it. Yeah, 0.317. Okay. So this part is nothing but 0.317 times dv. So this numerator is 20 and denominator is 63. So that's 20 by 63. All right. So now you just have to correspondingly convert this. You just put the dv values and you will get the x values. And you can do it in Excel or somewhere. You can get this easily if you just put the formula there and just drag it. But since I'm not going into Excel right now, I'll just quickly calculate and write the values. So let's try and do that. So first one is 52. So that's minus 10 plus 0.317 times 52, which is 6.484. So this is 6.48. Next one is 44. So this is 3.948. So this is 3.95. Next one is 29. So that's minus 0.81. So you can notice here that you haven't crossed that midpoint or something. So midpoint is 0 between minus 10 and 10. So, and here you have maximum decoded value could have been 63 from here. So you are still not in the halfway mark. So that's why you're getting a negative conversion. Next one is 11. So it's again in that negative half as well. So this is minus 6.51. Then you have 48 and 46. So 48 will give you 5.22. And finally, your 46 will give you 4.58. So this is your converted x values. Now, what you have to do, you have to plug it into the function, which is your x squared sine x. So now you can notice that all x values are lying within the upper and lower bound, so not an issue. So let's write the fx values right now. Okay, so yeah, you have a question, Manohar, go ahead. Yeah, yeah. Yeah, any value will not cross the bound. So that's the thing. If your any value is crossing that bound, that means you have done something wrong in your calculation. So the reason being is that yeah, the reason yeah. So the reason being that is suppose I am writing this equation again. This xi is xi x mean yeah. That was a verification that I have talked about. So now here you will just plug in the dv values, right? Okay. So now what can be your dv value? So if you know your x min, x max, and your dv values, you can get your some sort of a bound on xi. So the only unknown here is that your dv, x min, x max, and li is given. So suppose I use a string of length li. So string of length li. Suppose the maximum it can have its all ones, right? So suppose this is all ones and there are li number of ones here. And the minimum this can take, it's all zeros. Okay. So what you will get is that in case of this, the decoded value will be 2 to the power 0 plus 2 to the power 1 and so on, like 2 to the power li. Uh, there are li string length is li, that means this final bit will have a position li minus 1. So now this is a gp series, right? Gp series with an initial value 1 and then you have that factor which is being multiplied, which is 2, and then you have probably some li number of this. So you can have this summation written as 1 times 2 to the power li minus 1, and then you have this 2 minus 1. And finally, it will give you 2 to the power li minus 1. So this is the maximum decoded value that you can have. And for this, the minimum decoded value is 0 because you are multiplying zeros with the powers of 2's. So now, if you put the first one here, so this is x max minus x min divided by 2 to the power li, this is minus 1. And the dv value from here, which is the maximum one, is 2 to the power li minus 1. So this 2 will cancel out and you will be left with x max. Similarly, if you put the other one, which is 0, then that if you put this dv value here, you will be left with x min. So that means once you convert it, it cannot go beyond this bound. So it has to lie between x min and x max. So that's just a verification that that should be between minus 10 and plus 10 here. Otherwise, you have made some mistake for sure. So that's the thing. All right. So I think this is clear now. So let's do and write this fx function. So this is again you can just do it in Excel or somewhere else as well, R or Python, anywhere, so that will work. But let me do it quickly in my calculator. Okay, so this first one is 6.48. So when you do it in your calculator or maybe anywhere else, so make sure that when you are dealing with this trigonometric function, your calculator is in the radian mode because you're putting these values in radians. And also, I think that is automatically taken care of in other solvers like Excel or Python. So not to worry about that, but you need to be careful. You are not putting those in degrees. So let me do that. So I have converted my calculator into radians, so that's not a problem. Okay, so let's quickly calculate this. The first one will be 8.21. The second one will be 3.95 squared times sine 3.95. So that's minus 11.28. Next one is minus 0.81. So that's square times sine minus 0.81. So this will be minus 0.48. The next one will be, quickly, let me do this, sine of minus 6.51. So that will be minus 9.53. Next one is 5.22 squared times sine of 5.22 only. So this is minus 23.81. So you can notice that some of the sine functions are getting negative because it might lie in the second quadrant as well. So your pi by 2 is around 1.57 if you cross that, sorry, third quadrant, I guess, because sine in the second quadrant is also positive. So if we're crossing that pi value, probably 3.14, you are getting to that negative zone as well. And then this is just verification again. So final one is 4.58 squared times sine 4.58. So that will give you minus 20.79. So these are your converted like fx values in your solution pool that is that earlier given. So now, since you are dealing with a maximization problem, so this is good news that you have found out small fx. That means this is your fitness function that you already have. So this you can write it as, or here I will write it as capital Fx, which is the fitness function. All right. So now, this is just an initial part of this problem. The main part of this problem is you have to modify this fitness function. And this is with some sigma value of 5. So this comes directly from that discussion on multimodal functions where you don't want all your like you don't just need to find out your global optima in some cases. Probably you want to keep those local optima in your solution, or you may be wanting to find out all the solutions in your functions. So in those kind of situations, you are not bunching up everything to your global optimum point. You need to spread out all your points and get to those local optimal points as well. So that's the idea behind modifying those fitness functions. And the one that is having the highest value, we're kind of probably reducing it in terms of some sort of a method that I'll be discussing right now. All right. So for that, there are three concepts, I guess, 2 to 3 concepts to modifying the fitness function. So let me write this. So modifying fitness functions. So the first one is that the sharing function. So this is the sharing function. So this sharing function, you can write it in terms of SH, not a bracket, I guess. So let me write it as SH of ij. Now you can write it in terms of the distance between those points I and j. I'll talk more about how you can get that. So this is dij by sigma. So this is if dij is less than equals to sigma or less than sigma or whatever you want to write. and otherwise it is 0. So 0 otherwise. So now, what is Dij? So sigma is given that you already know, and Dij you can calculate. So you know this x values, right? So suppose I name them. This is my first point. This is the second. This is third, fourth. This is fifth and sixth. Now the distance between first and first point, so it's D11. This is zero because they were just dealing with that point only. Now, when you are dealing with the distance between 1 and 2, what you have this x values here, and you can take just a modulus of those distances. So this 6.48 minus 3.95, you can calculate, and that will give you a distance function. So take it as a positive value instead of negative, because in that case, if you take it as positive, your Dij will also, like, you can check that whether that goes beyond the sigma or whether this is less than sigma something. So now the challenge is to calculate all these Dij values so that you get this sharing function table. So for that, what you can do, you can do something like this. So say this is sharing function, and or you can, before going into sharing function, just get into the distance matrix kind of a thing. So let me write this as distances. So this is 1, 2, 3, 4, 5, 6, and this is again 1. So this is 2, 3, 4, 5, and 6. So there are 6 points in the solution pool. And the thing is, you know that your diagonals will be 0 because the distance between the point and itself is 0. So you can put those values in here, and this is 0. And you have to fill the rest of the values. And again, you can do that pretty in a simple manner. And if you're coding it, it's simple. You just feed those solution and you'll get the matrix out of it. So right now, I don't have like access to Excel or something, so let me just calculate it. So first one is 6.48 and 3.95. So if you calculate it, it will be nothing but 2.53, which is the distance. And the good thing about this is that if you calculate between 1 and 2, we'll get between 2 and 1 as well. So this is 2.53. And next is again 1, 3. So this 1, 3 distance between that will be 7.65. So let me do for 1 only, just for 1. Then I think rest of the table you can fill it up. So 1, 4, it's nothing but between 6.48 and minus that thing, 6.51. So that will be around 12.99. And the next one will be, okay, let me write this one first, 12.99. 1 and 5 will be 6.48 minus 5.22. So that will be 1.26. And the last one will be, I think, 1.9. Let me check, 6.48 minus 4.58. So that will be 1.90. Correct. Okay, so this will be 1.90. So this thing kind of tells you the distances between the point, the solution point that you have, the first solution point, and this between that point and all the other points or itself. So between that point and itself, this is always be 0. For other points, it will be something more than 0, obviously, if it's not the same set of binary string that you had generated in the solution pool earlier. So that thing we have got. Now, you have to fill the entire matrix, the distance matrix. I'm not going into the calculation of the entire thing right now. But the more interesting thing is the row of this matrix, so that you can notice here. But before that, we have to convert it into our sharing function ij. So now this you have to convert it into now sharing function table. So suppose this is my sharing function. Again, you have to create a similar table. You can do it in Excel or anywhere else as well. So this is 1, 2, 3, 4, 5, 6. This is 1, 2, 3, 4, 5, 6. Now, if you remember, this is your expression for the sharing function, and this is 1 minus dij divided by sigma, and sigma is given as 5, and only if your dij distance is less than 5, you will calculate this, otherwise you can just simply put it as 0. So now you can notice that for this and this, you can just directly put zeros because it has already exceeded your 5. So let me put this. So this will be 0, this will be 0. So that this kind of tells you, since the distance is pretty high from that point, so it's exceeding more than 5. So the solution, this 3 and 4 is not bunched up with 1. So it's already far away. So you don't even care about that. For others, so for 1 to 1, this is 0, right? This distance. So if you put this 0, the sharing function from itself to itself, it's always 1. So this 1 you will always get. So now the only thing that we need to calculate is the sharing function for the rest of the three. And since those distances are less than 5, so it kinds of tells you that those solutions are close to 1. And if it is very close to 0, you could have told that those solutions are bunched up and your sharing function would have taken a value of 1. And now we have to calculate this. So for the first one, it's nothing but 1 minus 2.53 divided by 5. So that will give you 0.49. For the next one, it's 1 minus 1.26 divided by 5. So that will give you 0.4748. I can write it as 0.75. And finally, it's 1 minus 1.9 divided by 5. So that will give you 0.62. All right. So this is how you can calculate your sharing function. And again, you have to fill the entire table. In this table, you remember that all the diagonals will be 1 because the distance is 0. So you can put 1s here. This 4, 4 will be 1, 5, 5 will be 1, 6, 6 will be 1. And this will again be kind of a symmetric matrix because you are dealing with the distances. The dij is also equal to dji for any set of pairs ij. So let's see how you can now use this sharing function and modify those fitness values. So the next concept that you need to know is the niche count. So that's another thing. So the next one is niche count, and this niche count is associated with every point of the solution pool. You can denote it as NCI, and this is nothing but summation of all the points. This is j equals to 1 to n, and this is the sharing function from I to j that you have to add it up. And here in this problem, you have 6 solutions. So n equals to 6 here. So that means if you fix your I value to 1, say I equals to 1, so this niche count, this is NC1 for that point, is nothing but the summation of this row, right? So you're just adding up everything. So this will be the summation that you can write it here. And for the first row, the summation will be nothing but 0.49, 0.75, and 0.62. So this will be 2.86. Yeah, hope I have done it correctly. Yeah, I think this is fine. So now, if all these points were the same, then you would have got one everywhere, right? This would have been one, this could have been one, this and this and this. So that means the maximum value of this niche count is nothing but n. That means the number of solutions that you would have had. And here it's n equals to 6. So if you had one everywhere, this could have been 6. That's the maximum one. So that's the factor by which you are decreasing kind of your fitness function values. And if the solutions are not bunched up, everything say was beyond, say sigma equals to 5 was given, so everything suppose was beyond 5, then you would have got zeros everywhere except for this value. So this will always be 1. So this sigma would have been 1 in that case. And if we divide the fitness value with 1, you would have got the same thing again. So that means when your solution pool is not bunched up, you are not modifying anything with the fitness function. If it's bunched up, then its value will go up from 1 and it can go up until n as well. So the more the solutions are bunched up, so if all of them are bunched up, then you would have divided your fitness function value by capital N. So that's the idea behind using the sharing function and niche count, and using this you can use those modified fitness function value, and then you kind of evaluate which solution you want to keep or which one you want to discard or something, so that you can get to the second best solution or the third best solution. Those we would also want to protect or something. So the third one is just modification of fitness function that I have already talked about. So, so this is nothing but your niche count, sorry, the fitness function, say of I, the ith point will be the previous one divided by this niche count. So let me calculate it for the first one. So this f1 of 1 prime, or you could have wrote it as capital F as well, since I was using it for uh, the fitness function and small f was for the function itself. Anyway, so I can use the same thing here because the function and the fitness function were the same. So this is uh, small f1. So I have already calculated my small f1 value, I think, somewhere beyond this. Yeah. So that was 8.21. So that was my fitness function value, which is kind of high in that case. And now you will be dividing it by 2.86. So this is 8.21 divided by 2.86. So this will be your modified fitness function value for that first solution point, which if you calculate, you will get it as 2.87. Yeah. So now you have to do this similar exercise for all the 6 points that you have in your solution pool. I have shown you for the one point. I think you can do for the rest of the 5, so that's not an issue. So it's just you have to fill the entire distance matrix table, and then you have to convert it into the sharing function table, and just take the row sums of every point and then divide it. So that will be a niche count, and just divided it with those niche counts, and finally we'll get to the fitness function, which is the modified one. So this is the idea behind it. So I think you'll get a couple of problems related to this in your assignment. I was earlier solving it yesterday, and I noticed that there are some issues with the choices that have been given. I was not getting similar signs or something. So that could be a mistake, but you just check and see if you are getting any solution from those 4 choices that have been given. If not, then again, that problem might be removed from evaluation. But yeah, we'll take care of it later. And yeah, I think the method is pretty similar for all those 2 problems. It's just the function value which is different, but you have to follow the similar step. And I recommend you to like fill up this distance matrix or sharing function in Excel itself, because that will save your time. So yeah, you can do by calculator as well, but yeah, whichever is convenient to you, you can use. Not a problem. All right. So this couple of problems I wanted to discuss. Then I have one more I want to discuss, but before that, any more doubts or anything related to the assignment or anything, then you can ask. Otherwise, I'll move to the third problem. All right. Yeah, go ahead. Do you have any question, Manohar? Yeah, I can do it right now, but you have to tell me the question but, clearly because I don't have it open right now with me. Okay. Hmm. Okay, okay. Yeah, yeah. Hmm. Okay, let me write it down. P1 101011 011 001. Okay, so crossover site was given as 3, right? Yeah, so I think what you are asking is I have understood that I think in the previous class, I think I was discussing this and I think I made some mistake. I said that this is your crossover site and just crossover from this point onwards, but I was going through the lectures of this session of search lectures. Where I noticed is that if your crossover site is 3, you're kind of breaking it down from here. And then you are just moving this part to after this, and then probably you are moving this part after this. So that is the thing you have to do. So your uh, child one should be 101001, and your child two should be 011 011. So this should be your answer. I think in the previous class I made some mistake, but it's again some sort of a doubt that is also there because in some of one of the assignment question I think uh, it was not clear. Even if you switch it from that second or the third portion, I think you would have got the same answer or something like that was there. But I think this is the correct one you should follow. It's just to break it down from that portion and then just do the crossword. Yeah. Oh, okay. Hmm. Yeah, yeah. So I think we'll communicate. So I think in that, there what they are doing. So this is the confusion. I think in two both weeks lecture there is this doubt. So I think they did from here only. This is if the crossover site is 3. I think they're kind of breaking it down from here and then doing the crossover. So it's that issue is there, I guess. So yeah, that accepted answer. Yeah, I'll note it down. Okay. Yeah, sure. Go ahead. Hmm. 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 Yes, yes. So I think if that is given, the crossover site from 3, then you have to cross over everything which is there from that point onwards, from like in towards this right. And I think in one of the assignment problems in this class, this week's content, I think they are given some between some 3 and 5 or something, I think given. So I think you cross over only those portion which is between that range. So that's another thing that you have to keep in mind. So I was going to discuss that only right now. So let's do that. Uh, so the problem, I think, it's some common data problem that's been given in this week's assignment problem. So let's discuss that. So there, what you are given is some 8, say, bit kind of a chromosome, or these you can think of as a gene. So now your fitness of an individual X is kind of written as A plus uh, B minus C plus D. I'm just flipping it around. Suppose this is minus C plus F plus G plus H. So this is how you can calculate your fitness. And now, suppose I'm given you 4 chromosomes. Say right now, since there is not much time, I'll just deal with 2 chromosomes and solve this. Suppose this is 6 4 5 4 1 3 5 3 2, and this is the second one, 87126601. Yeah. So now this is your A, B, C, D, E, F, G, H. So for the both of these chromosomes, you can calculate your fx1 and fx2. So for the first one, you can just have 6 plus 5 minus say 4 plus 1 minus 3 plus 5 plus 3 plus 2. So this is simple. So you'll get 11 minus 5, that's 6, minus 8, so that's minus 2, then this is probably plus 3. And for the second one, you will get say 15 minus 3 minus 12 plus 1. So I'm not writing everything down, so I'm just summing everything, these twos together. Okay, so you'll get probably 1. So now you'll be asked, just evaluate this fitness and just arrange them from fittest to the least fit. So in this problem, it will be this order will be x1 greater than x2, something like that. So the problem that is given in the assignment will be something kind of different. And then there will be questions of doing some sort of a crossover at say using 1 point crossover. So this is one concept, 1 point crossover. And say at the middle point itself. So for that, what you can do is just break it from here. And the childs that you will create will be 6541. Then this is 6601. And the another solution that you will create is 87123532. So this you can think of as x3, or this is, could be your x4. Then there could be questions like this cross the uh, first and says this x1 and x2 using 2 point crossover, say at B and at F. So that was I was talking about. So another one is 2 point crossover. So here, suppose you are given those two strings 6541. Uh, this was let me write it down 3532 87126601. So now I am telling you this B and this F. This is your portions where you have to cross over. So for that, what you have to do, what I understood, is for a 1 point crossover, if it was given as B, you would have broken from here and just replace everything from there onwards. And now, similar thing you will do, you'll break it from this two portions after this B and this F and this portion as well. So we'll just flip those around. So from this, you should get childs of 651266. Then you will have that 32. And then from this portion, you will get 87. Then this 4135 portion will come here and you will get 01. So this is the portion that's being changed. So this is the child 1 and child 2. So this is the basic difference between this 1 point crossover and 2 point crossover. And then I think it was asked, so this was there. Then, yeah, cross between say first and say third fittest, okay, using single point. Okay, so another one could be like single point crossover, but also probably it was given between C and D. So let me write it here as well. Suppose this is 6541353287126601. Suppose I'm telling that between C and D, you just cross over this thing and with a single point crossover. So for that, what will happen is that this C will come here in this place and this, so that will be 871, then it will be 4. And for the other one, what will happen? It will be 654 then this one will go from here, this from here to here. So it will be the same thing again. So that's the crossover, single point crossover between say C and D. So it's just flipping this that C which was there in the parent one that will probably go as a D into parent two, and the C that was there in parent two will go as a D in parent one. So those are the main differences of crossovers. Whether it is being asked as a one point crossover, from that point onwards, then you will do for the entire right portion. If one point crossover is between two sides, you will just do this kind of a thing that I just discussed. If there is 2 point crossover between two sides, then you will just break the entire thing and just flip everything around. Like this 4 bits you are flipping around. All right, so that's the distinction. And then I think from that you will be asked multiple questions like which are the children's that is being created, and from that you will again be asked to calculate your fitness function using say this equation that I have already written. So, and then you may be asked like whether your fitness function has improved. So suppose this was earlier 3 and 1, whether you have got something like 5 or 10, or whether you're getting something -5 or -10. So based on that, you can judge whether you're improving or not. Then I think there was one question on the optimality. Okay, so let me briefly discuss that. So in this kind of a setup, suppose this is your optimality. So your fitness function was given as a plus say b minus c plus d minus e plus f plus g plus h. And your strings are this a, b, c, d, e, f, g, h. And this can go from 0 to 9, this a to h, all this. So now, since you are summing this up, this one, this one, this one, and this one, and the positive portion are from this one. So this is positive because you're adding it, and these parts are negative. So the optimal value for which this fx is maximized is if you are kind of minimizing this portion. So if this is 0 and 0, so this summation is 0 and you are subtracting 0 from the entire thing. So that means this part, the effect of this part and this part you should eliminate. So this you need to set as 0 and 0. And this part, say 9, 9, you can set. So you are getting 18 from this portion and again 18 from this portion. So that means this a plus b you should maximize, g plus h you should maximize, and c plus d and e plus f you need to minimize. So this is the string that will be x optimal. So it will be probably asked a similar problem in that, where there I think the setups of the signs are slightly different. And again, the maximum fitness value in this case will be just summing this every entire thing, and that's probably, and this these portions are 0, so this will be around 36 or something. So I think we'll probably get asked this question as well. All right, so this is the main thing. So real coded GA is another thing. So you'll probably get some sort of a true false type questions or some like basic conceptual questions as well. I think those you can easily answer, so that's not a problem in this assignment. Yeah, so the main problem in this assignment was the modifying the fitness function using those concepts of multimodal functions and all. So that was discussed. So that's a good thing. And if I just quickly check the content of this week, I think this real coded GA portion does not have much assignment problem. Just this crossover and all was being asked, but this crossover can have like multiple techniques where you take half of one solution and half of other parent solution and just modify that and do some sort of crossover from that portion. Or you do 1.5 times of say one parent and minus 0.5 times of another parent. So I think those were discussed in the class, but you won't get asked questions related to that here at least, but in the exam probably that will be there. And then this alphas and the 1 minus alpha, those factors were discussed and think. And then this mutation and everything when this came, the simulated binary crossover also there. So they're kind of doing this modifications using some sort of a probability distribution. So that's another thing to keep in mind that you can do those. And those simulations probably you can do in anywhere like R or Python or anywhere else as well. So this is all about today's content. Do you have any questions? So next week, you can ask if you have any questions. So next week, I think it will be R coding will be discussed, introduction to R and some this solving this genetic algorithms problem using R programming. So I'll next week I probably won't use this kind of a pen and paper kind of a thing. So I'll probably solve most of the problems in R software itself. And I think all those instructions and everything have been given how to install, download, and everything. And so it will be good if you do it with me as well in your laptop. So that will be helpful. And if you have a specific doubts related to installations and everything, you can ask in the next session. All right. So do you have any doubts? Otherwise, you can join the other session.